Okay, I have started scaling of Synapse to DW400C. It will give us a bit more performance compared to the base one. And while this is scaling, let's take a look at how can we actually migrate data from SQL Server, for example, or Oracle to Azure Synapse Analytics. So we start the same way. We're going to be selecting a demo database that I have here and continuing next. And now we're going to simply be selecting Azure Synapse Analytics here. I have connection saved already, so I don't have to pull out the storage. So the connection is basically the simple connection to SQL Server with some additional authentication modes. And another part we have here is storage. As I mentioned in an earlier video, it would be efficient to load data row by row into data warehouse because data warehouses use columnar storage under the hood. To ingest data efficiently into Synapse, we need to use intermediate data lake. We can use Azure Blob Storage, ADLS version 2, so that's the default, and we can load data in CSV or in Parquet, and we can specify the compression to be none, gzip, or snappy. Usually, the most performant mode is Parquet with snappy, so that's what our defaults are. And let's see if this has... No, it's still scaling, but we might actually go ahead and try and see if we can connect. If set will allow us to connect at this point, we're going to be reading its metadata and we'll know exactly what's in it. And we have made it, right? Okay, so as it was in the earlier simpler scenarios going from SQL Server to Postgres, you can see that also for Synapse Analytics, all I had to do is connect to it. So there was nothing additional to do. We are now reading metadata from source and target in parallel to understand our database that we are dealing with. Under the hood, let's see if the scaling is complete. Yep, it is. Okay. Again, we have 10 billion records here. Let's deselect some. So select a few of these ones, let's say this, and then some small ones, and then some. I think we have mid ones. Yeah, let's select some mid ones with 1 million records. Let's select some tiny ones. And we can select tiny with 100 million records. And then let's just select one with 1 billion records. So now we have selected 1.2 billion records, 70 gigs. And we're going to be loading all of that over the internet to Azure Synapse Analytics. So how hard can it be? Let's give it a try. All right, so we are using a thing called streaming load. So that's an algorithm. We have several algorithms depending on the environment and what you need, and you never need to worry about it. And if you go into Task Manager now, we should be seeing that our CPU is completely packed. We might even lose connection to our remote server that we have remoted in at this point because the machine is completely killed by this. And why do we use so much CPU? Because we are actually now, and if you go to Ethernet here, we are actually now uploading all of these Parquet files to the data lake. So what we are doing is we are streaming data, reading it in many parallel connections. So we have many workers running in parallel, reading data from the source SQL Server tables, creating Parquet streams, so Parquet data files in memory. And Parquet is a columnar format and highly compressed. As each Parquet file is being completed, it's being uploaded to the data lake as soon as all parts of a specific table, or if you would use repartitioning, that we also can use it on the loader. So as soon as each Parquet file, as soon as all Parquet files for a specific table or partition are ready, we are firing up ingestion. You can see this here, right? So this one is being completed. All of its files are being uploaded to the Azure Data Lake. And as soon as all its files are ready, we are firing up ingestion while continuing creating new Parquet files, uploading Parquet files, and then again, as soon as each table is completed, we are firing up ingestion on the Azure Synapse Analytics. While this is being done, we can take a look at what do we actually have in our data lake. So to do that, we'll fire up Azure Storage Explorer. And so we have, just a moment, let it open a bit. So we have ADV container. And then we have, or was it a demo? Let's see. Oh, it was a demo. MS demo, and then we have this one. Currently, we are grouping this by schema, and then we can go into any table, and then we have hot storage. So this is for a dedicated SQL pool, and we have Parquet file. Go up, we can go to see another one, and then we can go here and we can see another file. But let's see tiny 1 billion one, right? Which was much more of these ones, and it's not complete yet. So as it is being uploaded, we are creating all of these Parquet files, and as soon as they are done, all of them, we're going to be ingesting things into Synapse. So by now, I think we have copied all of the tables, but this largest one of 1 billion records, and this largest one has all of our cores, all of our agents on this machine, sorry, all of our workers on this machine, running in parallel to compress things. And the performance is currently limited by the CPU power that we have. So if you would be running this on a, say, 32 core machine or even 72 core machine, it will go much faster because you'll be able to compress Parquet files much more efficiently. If you see at the memory, I'm pretty certain that this is Oracle and SQL Server stealing the show here. Let's see. Yes, of course. So Omni Loader is not using a lot of memory. We only use 2.8 gigs to migrate all of this. All right, this concludes this video. You can see it's exactly the same process, whether you're dealing with something small, something large, whether you're working with relational databases or the data warehouse.